So welcome friends, today we are going for the session 5 and this session contain high frequency registers. So individually we will go for one by one component and we will see what are the effects coming from high frequency. So aim of this session is to familiarize the students with the concept of high frequency registers. Instructional objective is demonstrate RF behavior of a resistor, describe the construction minimizes parasitic effects, describe about problems associated with a piece of wires. Learning outcomes: how does an ordinary resistor element behaves at a micro frequency? Second one, understand or work with signals in different fields. So we are thinking about how does an ordinary resistor element behaves at micro frequency. So do you agree or not? A carbon resistor at micro frequency, that is about 10 GHz, if you are telling about an example, has a stray capacitor. Already I told the capacitor it will behave like a stray capacitor and a stray inductor as well as a higher resistance due to skin effect and radiation. So due to skin effect and radiation, so there are stray capacitors and stray inductors associated with the resistor. Do you agree with this statement? Is it due to as frequency is increasing, the cross section is reduced, that is known as our skin effect. And second one, part of power is lost in the air, that means radiation. So this due to two things we are achieving stray capacitor and stray inductor. So that means this is most important points we need to discuss. So if you are thinking about the DC world, then we can write V equal to Ri, and low AC also we can write V equal to Ri, but at a high RF microwave it is not, V is not equal to Ri. What is this is Ohm's law, already we discussed. Ri means I is the current, R is the resistance, V is the voltage. Okay. So now if you agree to the above, then we are getting a stray capacitor and inductor need to be added into the equivalent circuit. So now you can think, if it is a resistor, then this resistor, where if you are thinking about the high frequency, then we need to increase, means give the stray capacitors and inductors we need to add with the resistor. Now we can see how the peculiar thing. So addition of the extra parasitic elements in the equivalent circuit is necessary because the combined length of the leads and the component size itself is comparable to the wavelength. So that is most important, because here the wavelength and the size of the thing are comparable. So if you are thinking about this, in low frequency electronics, resistor is to produce a voltage drop by converting some of the electric energy into heat. It is agreed? We are agreed, all are agreed in this sentence. So now we are going to know about types of resistors. So we have, I have basically given 4 types of resistors, those who can work under high frequency. One is known as your carbon composite resistors of high density granules, wire wound resistors of nickel or other winding material, metal film resistors of temperature stable material, thin film chip resistor of aluminum or beryllium based material. So if you will take this type of material, then this resistor will work at the high frequency configuration. So you can see so many, means I am showing some figures. This is a wire wound resistor, that is a metal film resistor, this is carbon composition resistor, these are known as your small resistors, and these are known as your small resistors where we are using this type of resistors, and this is rheostat, it is a wire wound resistor. I have given some examples what you already covered in your first year basic electronics. Now I have written here carbon film resistor, solid resistor, metal means metal thin film resistor, metal oxide film resistor, metal foil resistor, metal plate resistor, then others are cement resistor, enable wire wound resistor. So these are the types of resistor what are available in the market. From that only that 4 we can use for the high frequency application. So you can see Why we can't use the others one? So why this capacitance, inductance are coming into existence? So for that we are thinking about two things. One is known as your skin effect, one is straight wire inductance. So if you are thinking about as frequency increases, the electrical signals propagate less and less in the inside of the conductor due to the skin effect. Second one is the current density increases near the outside perimeter of the wire and causes a higher impedance to be seen by the signal. This is because resistance of the wire. The resistance of the wire already we know from the 12th class are equal to sigma means rho L by A. So this is rho L by A. So L is the length of the wire and A is the area of cross section, rho is the, what is that rho? Rho is your density. Now if you are thinking like this, if the effective cross sectional area A decreases, this leads to an increase in resistance. So that means here you can see if A decreases, then resistance will going to increase. So here the resistance increases. So if this is the cross section, then it is R1. If it is cross section increases, then this resistance also increases. But if you are taking the RF case, DC case, okay, the R1 we can get like this. But if you are thinking about RF case, then due to this circle, it is behaves like an inductor. So that means resistance is there, but it is going for a inductor. So resistor and the inductor are series if you are thinking about the RF case. Now if you are thinking about one example, I have given one example for wire wound resistor. Here you can see this thing we already corrected, but now we are adding again. So sorry. So this thing, so here this thing, this resistor, this we are getting from the previous one, but now we are adding one inductance, more inductance. Why that inductance? L1 and L2 also. So this inductance why we are added? Because of wire wound. So if the wires are wound, so the wound means it is behaves like an again one inductor. So we are adding one inductor and added some capacitance value to the other capacitor C1 and C2. So these are the one example I am just taking care when I am giving the theory or practical about the resistor. So now I am thinking about the self-assessment questions. So I am asking two questions. High frequency resistors are designed to have what? The most common type of high frequency resistor is this four. Choose one and we will solve it. Now if you are taking about terminal questions, these are the terminal questions. We can just discuss and make the everything, make it solve. If you have any query, you can contact to me. Reference books, so these are the reference books, and thank you. I am Dr. Arjun Mudali. Thank you on behalf of KL University.